Hey everyone, welcome back. I am absolutely thrilled you're joining us for today's Explainer because we're tackling a really fascinating and honestly absolutely crucial topic in the world of corporate sustainability. Have you ever stopped to wonder how we can fairly evaluate environmental impacts across companies of vastly different sizes? Think about it. How do we look at a massive multinational corporation on one hand and a small regional business in the pulp and paper sector on the other and actually compare their performance without the data being totally skewed? Well, that's exactly what we're going to unpack today by diving into the SASB standards for this industry. Let's get right into it. Okay, let's look at our roadmap for today. We'll start with the flaw in absolute data, then introduce SASB activity metrics, define sourced wood fiber, see how to calculate sustainability intensity, and wrap up with the power of normalization. Section 1. The flaw in absolute data. Before we look at the solution, we really need to understand the stakes for ESG analysts when they're forced to rely purely on raw, absolute environmental numbers. Picture this. You've got a massive, intimidating global paper giant manufacturing millions of tons of paper every single year. Naturally, their absolute total greenhouse gas emissions and water consumption are going to be massive, right? Now, compare that to a quaint, rustic little boutique mill. Their absolute emissions and water usage are practically tiny. If an investor only looks at those raw totals, the local mill looks infinitely more sustainable. But you know what? That's an apples to oranges absurdity. It completely ignores their scale of production. The global giant might actually be way greener per page of paper using highly advanced, ultra-efficient closed-loop water systems, while the local mill might be incredibly wasteful on a per-product basis. Raw data simply doesn't tell us the truth about operational efficiency. So, this brings us to a pivotal question for anyone looking at corporate sustainability. How do we actually compare their data fairly? How do we find that great equalizer so we can tell who is really operating more responsibly?
Section 2. Introducing SASB activity metrics.
This brilliantly illustrates the exact tool analysts use, activity metrics. Notice how incredibly clear and defined they are here. These aren't metrics about pollution or resource depletion. Rather, they're quantitative metrics designed specifically to measure the sheer scale of a company's operations. Let's walk through these three core activity metrics together. First up, labeled code RRPP-000.A, we're quantifying pulp production, and that's measured in air-dried metric tons. The second one, code RRPP-000.B, quantifies paper production, also in air-dried metric tons. And finally, the third metric, code RRPP-000.C, quantifies the total wood fiber sourced, which is simply measured in metric tons. By requiring companies to disclose these three very specific numbers, the standard guarantees that analysts have the exact data they need to understand the fundamental scale of the manufacturer's output and their raw material intake. And hey, crucially, notice that shared unit of measure, metric tons. Keep that tucked away in your back pocket for the math we're going to do in just a minute.
Section 3. Defining sourced wood fiber.
Now, ESG analysts absolutely love precision, so let's look closely at the definition provided for that third metric, RRPP-000.C. Total wood fiber sourced is defined as all wood fiber-based raw material inputs processed to be sold as a finished good. The accounting rules here are incredibly strict. You can't just throw literally any wood product a company buys into this category. It has to be processed with the specific intent of becoming a sold, finished good.
Now, what's really interesting about this is the explicit breakdown of what's in and what's out of this calculation. The scope explicitly includes recycled raw materials, virgin raw materials, and goods that'll be consumed directly in the production process. But look at that last bullet point. It strictly excludes biomass for energy use. Why is this so absolutely critical? Well, pulp and paper manufacturing is highly energy intensive, and a lot of facilities burn biomass to generate power. If a company included the wood they just burn for energy in their sourced fiber metric, it would wildly distort the data regarding their actual product manufacturing scale. The SASB standards handle energy consumption entirely elsewhere, specifically under metric 130A.1, ensuring that this activity metric remains a pure, unclouded reflection of material inputs for production.
Section 4. Calculating sustainability intensity.
Okay, let's see how all of this builds a completely new way to evaluate performance. To figure out how efficient a company truly is, we just create a ratio. The environmental impact acts as the numerator on top, and the production scale, our handy activity metric, acts as the denominator on the bottom. So, say you want to figure out emissions intensity. An analyst takes metric 110A1, which is the gross global Scope 1 emissions, the direct greenhouse gases emitted into the atmosphere by the company, and divides it by our activity metric, RRPP000B, the tons of paper produced. It's the exact same idea for water intensity. You take metric 140A1, which is the total thousands of cubic meters of water consumed, meaning water that evaporates, gets incorporated into the product, or just doesn't return to the source, and you divide that by metric RRPP000A, the tons of pulp produced.
By doing this simple division, what do we get? Boom, we finally arrive at a standardized sustainability intensity ratio. We are no longer just looking at total emissions or total water. We're looking at emissions per metric ton of paper and water consumed per metric ton of pulp. This mathematically strips away the size of the company, leaving us with a pure, undeniable measure of their actual operational efficiency and environmental impact.
Section 5. The power of normalization.
So as you can see, normalization really acts as the great equalizer. These activity metrics allow investors to see who is actually manufacturing paper and pulp most sustainably per ton, not just who happens to be the smallest operator in the market. It rewards the companies that are actually investing in efficient technology, closed-loop systems, and better resource management, even if they're massive global giants. It brings transparency, fairness, and true comparability to the entire pulp and paper sector. I want to leave you with this final thought to ponder today. When we apply this kind of mathematical framework, does normalization just change how the data looks on a spreadsheet, or does it completely change the investment landscape, shifting capital toward the truly efficient innovators? Keep that in mind the next time you're evaluating an ESG report. Thank you so much for joining me to explore this incredible analytical framework. Keep learning, stay focused, and I'll catch you in the next explainer.